Annuities. This is the next part. The calculations used to model the values of reducing balance loan and annuities are pretty much the same. Okay, they're identical. So guys, the only difference is that the value of the loan represents how much is owed at any time, whereas the value of an annuity represents how much money that is left in the investment. So let's have a look at what an annuity is first of all. So annuity is just a payment made to you at regular intervals, if you choose them at regular intervals, either monthly, fortnightly, whatever, for an investment. But the way we do reducing balance loans is pretty much the same, and you'll see that over here. Looks like a reducing balance loan anyway. So let's go through this. So let R be the interest rate compounding period. Let D be the payment received, the money that you're going to get. And we will model this via VN. So our initial VO is your principal amount, as we've done before for reducing balance loans. VN plus 1 equals RVN minus D, where you know that, guys, R is 1 plus R on 100. Example. Reza plans to travel overseas for 6 months. He invests $12,000 in an annuity that earns an interest rate of 6% per annum, providing him with a monthly income of $2,035 per month for 6 months. So this guy wants to go on holidays. He's got 12 grand. He wants to put it into an annuity, and he wants to pay himself $2,035 every single month. Okay, so now they're going to ask us to model this relationship. You've done this stuff before, but it's easy. So it says use VO as your principal, obviously, and use this formula to model it. So guys, what do we know from this? We know that our initial investment is $12,000. So I start to write down what I know so that I can plug it into this equation. Okay, so after N payments, so what is the value of our N? Our value of our N here is 6 months, because we want to pay this off we want to get paid for it in 6 months. We know that our interest rate at the moment is 6% for the year, so we're going to go monthly. So 6 divided by 12 will give us 0.5%, and 0.5 divided by 100 as a decimal is 0.005. So we're going to use that for calculating big R. So that would be 1 plus the rate, which is 0.5 divided by 100. But in this situation, we've already done that there, over here, and that'd be 0.05. So our big R in this situation is 1.005. And we also know that D is $2,035. So we have to write it down as they want it in this situation up here. So our initial VO would equal to 12,000. We write that down. Then we go V of N plus 1 equals 1.005 times Vn minus 2035, because that's your D and that's your R and that's your Vn. So we're just substituting, and this is what you want to do to get your answer for that one. Another example, look at this example 12. So in example 12, this one here is saying you've done all of this, so there is the relationship. So they're saying rent can be modeled by the recurrence relation, which you've done. Use your calculator to determine recursively the value of the annuity after Reza has received 3 payments from the annuity. 3 payments. So let's do this by modeling the recurrence relation on the graphics calculator. So you've got this table here that they've shown you how to do it. So what we do is, for this situation, we press 12,000, like so, times 1.005 minus 2,035, and we press enter, and you can see we get 10,025, which is there. Now we've got to tell the calculator to make that recurring all the way through, and we just want to press enter all the time. So all we do now is you've got 10,025 as your answer, so then we just hit times 1.05, that 1.005 because it gives you ANS, 1.005 minus 2,035, and now you can just press enter, 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 enter. And you can see that now this over here looks like this over here. And then you can answer the set questions. So the first one said, use your calculator to determine recursively the value of an annuity after Reza has received 3 payments. After he's received 3 payments from the bank, the amount that is there is $6,045 So you just count that. Now the next part of the question obviously asks you, is the annuity fully paid out after 6 monthly payments have been made? Well, 1, 2, 3, 4, 5, 6. No, he's got 6 monthly payments. That was the balance. So no, not really. There's 88 cents left. We want to make that 0. So his last payment would have been $2,035, wouldn't it? So what we've got to do is go back and calculate 88 cents on top of the 2035. So 2035 plus 88 cents, you don't even have to do it there, is $2,035.88. So that's his last payment to make sure that it's fully done. But you can do that on the calculator as well. Let's have a look at the amortization tables for annuities. Now you've seen an amortization table before for reducing balance loan. They're pretty much similar. So an amortization table for an annuity shows the payment number, which is there. So we've got 6 months worth of payments here for Reza. The payment received, the interest earned, the principal reduction, and the balance of the annuity after each payment has been received. So look at the properties of this over here. So if you look at interest earned, the interest earned is the interest rate compounding period times the balance. So for example, if you look at week 1 over here, we know that it was 0.5% of 12,000, which was $60. So what we're doing here is actually working out the interest earned for that there. So in the situation here, it says principal reduction equals the payment made minus the interest earned. So the payment made was $2,035. The interest earned was $60. So 2,035 minus 60 gives me 1,975, which is that value there. That's the principal reduction. So the balance of the loan, so what's left over, the previous balance minus the principal reduction. So the previous balance was 12 minus that bit there will give me 1,025 right there. And then you just keep repeating that whole process throughout. So that's the situation to get your 10,025. So the total return from the annuity, the sum of the payments made. So well, you guys know that this guy's getting paid $2,035 every month. The last payment was 88 cents extra because you saw that from our recurrence model. So for this annuity, the return of the investment was $12,210.90. So he actually earned for this annuity an extra $210.90 by putting it into an annuity and paying himself out each time. So that's the property of annuities. Fairly straightforward. Now let's have a look at doing some questions on the graphics calculator. Let's have a look at doing these questions on the graphics calculator. Right. Joe invests $200,000 into an annuity, paying 5% compound interest per annum, compounding monthly. So he's investing. So what we've got to do here is we can actually start putting in some information. So let's go. He's investing. So he's giving money to the bank. So the present value that he's got to give the bank at the moment is $200,000. So he's giving it to the bank. So it's a negative $200,000 will go into there. Now we know that the interest rate at the moment, so that's that one, interest rate at the moment, so we're going to put in. So we can go into the interest rate there, and that would be 5% in there. Now the first question, if he wishes to be paid monthly payments for 10 years for monthly payments, that would be 10 times 12, which is 120. So our N value in here should be 120. So I can go into that one and put 120 into there, and we know that that's the situation so far. So we've got that information there. It's monthly, so PPY and CPY can be 12 and 12. So we can put 12 and 12 into that one, and we need to actually work out the payment. The future value for the annuity would be 0. We need this one here, so we can press enter into there, and we will get $2,121.31 for that. So Joe will receive $2,121.31 each month from this annuity until it dies out after 10 years. So quite straightforward. Now, let's look at the next part of it. So it says in the next part, if he receives a regular monthly payment of $3,000, how much, so $3,000, how long will the annuity last? So give your answer to the correct nearest month. So the payment should be here, $3,000, sorry. So we'll change this to $3,000 for that one. And what we need to do is try and work out how long that will last for. So they're actually asking for the value of N this time. So this is the one that we need to work out. We press enter into that. And from that, you can say that Joe's annuity will last 78 months. Fairly easy. And the last part, that question 3, what interest rate correct to 1 decimal place would allow Joe to withdraw $2,500 each month for 10 years? So again, 10 years, that would be 120. He wants to withdraw this time in this situation here, $2,500. He wants to actually get back from the bank $2,500. And they're saying in the question, what interest rate will that happen at? So we've got to find I there. And the interest rate for that to happen for 10 years would have to be at 8.689 or 8.7%. So Joe would require an interest rate of 8.7% per annum to make those monthly withdrawals of $2,500. Very easy. And now you can have a go at doing exercise 9.